Welcome to this next tutorial, and today we're going to be looking at the PCA9685 PWM Servo Control Driver Board. That's a mouthful. We'll just call it a PCA9685 for short. Right, these boards, very useful boards. The reason I'm doing this tutorial is it's a lead up to some projects that I'm doing for model railways. Let's just have a quick look at one of these boards. So here we see the board, and along the bottom you've got a row of yellow, red and black pins. The yellow is the signal pin, the red is 5 volts, and the black is the ground. Now you'll see this little green connector dead center. This is so that you can supply the board with a separate 5-volt power supply. And that's because if you think you're going to be able to drive 16 servos off your little Arduino, you're kidding yourself. So you'll get away with powering 1 or 2, but if you want a lot of servos moving simultaneously, you are going to need a separate power supply. Now, you've got the pins on the left hand end of this board, and these pins are mirrored on the right hand side so that you can daisy chain these boards if you want. Up on the top right here are some solder pads. You can use these to change the address of the board, because these boards you actually send the code to a specific board address, as we'll see in a bit, because this is using the I2C or I2C, however you want to pronounce it, communication. Now, because you can change the addresses, it means you can have more than one of these boards attached to your Arduino at the same time. In fact, daisy chaining these things, technically it's possible to connect 62 boards, which would allow you 992 servos. You're going to need quite a bit of power to move that lot, but as I'm interested in model railway controls, these are primarily for animations and points or turnouts, depending which side of the water you're from. But I think if you've got over 900 turnouts on your layout, that is a huge layout. So let's get on with the tutorial. So stage 1 of the tutorial, wiring the things up. Now if you go to the Digital Town website, I've given a full list of connections. We've got a diagram that makes it a little bit easier, and you'll see I've got an Uno, a Mega and an ESP32. I've put the connections in. They vary from board to board. The strange thing is, because you don't have to actually call the pin number, it doesn't really affect your code depending which board you are connecting to. Now, next bit with this, if you have some other boards, I've put a link into the wire reference. Let's just bring this up. So here we have a list of other Arduino boards and the various pins that can be used. You'll notice some boards have 2 interfaces. I've used the Arduino Due and used 2 I2C channels at the same time for 2 items with the same address, but basically your list of boards are here with the I2C pins. If you're using boards from other manufacturers, then you're going to have to look it up on their various data sheets. So the wiring is quite simple. Get the basically you're going to finish up with 4 wires, a ground and a 5 volts. These are, or actually you can actually send 3.3, I think will work on these, but that is different to this 5 volts, and you need to be aware of this. These connections here are powering the electronics in the circuit. This 5 volts is powering the servo. Different things. There is a way that you can put 5 volts through the one end pin here that will power the servo, but I would advise you to use this connection because it has a few little bits of electronics in there that will, if you get the wiring the wrong way round, won't blow the board up. You've been warned. That's it. So before we start, the first thing we need to do is do a test. The reason we're going to do a test, the wiring diagram looks simple. I've helped a number of people with different projects over the years, and I can tell you that probably 90% of the issues that I come across when people are doing projects with the Arduino is not the code. It is their wiring. Yes, we love our breadboards, we love our little plug-in connectors, but the wires break, things aren't connected. So before we start screaming at the code, let's do some tests to make sure we've got it all connected correctly. So our first test, let's bring up the IDE, and what we're going to do is we're going to go to examples, we're going to go down to wire, and in the wire there is the I2C scanner. Going to load that up. Let's just upload this to my board. He says better plug the thing in. Here we go, won't take long. Open the serial monitor. Hang on. There we go. And here we go, you'll see it does a scan every couple of seconds, and you'll see it has found my device at 0x40, that's hexadecimal 40. Now sometimes you will see two addresses appear, sometimes you'll see one, I think it's 0x70. Just ignore that one, there is a reason it does appear now and again. Obviously if you had more than one board and you've soldered some of those tabs, you will actually see other boards appearing here, or if you've altered the one board that you've got, you know, that's going to be a different number. But if you're seeing this and you're getting this value coming up, you can smile to yourself and go, yes, I have connected the board correctly. We're ready to move forward. Now, after the excitement of seeing that the I2C scanner is working, let's now go to our next test. But before we do this test, we need to make sure that you have the libraries installed, and the library that you need to do a search for is the Adafruit PWM Servo Driver library. If you don't know how to get to the libraries, I suggest you do one of the first tutorials I did, which explains the way around the Arduino IDE, because I'm not going to go into that now. There's a list here of basically what you click, but we're just not going through. Get it loaded and get started. Then what we're going to do, if I just scroll this down, you'll see we're going to go and we're going to use an example. What you need to do is plug your servo in to port 0. You could actually pull it into any for this initial test, but I would tell you to put it into 0 because that will help you with the sketches that are going to come next. So when you've done that, then go to File, Examples, and you will see, if you have loaded the library correctly, the Adafruit PWM Servo Driver library, and then go down the bottom to Servo and load that sketch. Now, I'm not going to go through this sketch in any real detail because right now we're just going to do a test. So just accept that this sketch works. We're going to fire it up, and believe it or not, I am not going to show you the video of the servo moving, but I am going to get the serial monitor open. So here we see the 8-channel test started. In fact, what I'll do is just start that so we've got rid of all the previous stuff. So what this is doing on my desk right now, because I've got my servo plugged into channel 0, it's just moved backwards and forwards, and then what this is going to do is work its way through the various channels. Now, just so you know, it's only going to do from 0 to 7. If you plug in from 8 to 15, it's not going to go there, and that's purely because the way the code is written. So let's get back to that COM port, and we can see it's working its way through. But when it gets to the number that your board is plugged into, you should see your servo move 180 degrees backwards and forwards a couple of times, and then it'll stop while it works through. If that happens, congratulations, you've plugged your servo in correctly and everything is working. Guess what? It's got to 0. My servo's moved again. Right, now to get on to the sketches proper. Now, I told you not to worry too much about this example sketch, and I'm going to show you why. That sketch uses two different methods of moving the servo. So if you look at the example PCA9685 Servo version 1, which is, again, it's on the Digital Town website. The link will be below the video, so all the code is available to download. So if we go to that sketch, what I've done is taken the Adafruit example and I have ripped out as much as possible. So let's have a look at this. Obviously I've put some pins in the top, told you what it's going to do. It's going to move your servo backwards and forwards through 180 degrees, and as you read through this, I'll be honest with you, when I first looked at this, I thought this is not the easiest of bits of code to understand. You've got this US min 600, US max 2400, the servo frequency 50. All gets a little bit complicated. The servo frequency actually is part of the setup routine. There's also an oscillator frequency. The reason this servo frequency is set to 50 is that is what servos require. I'm actually using one of those cheap MG90s. You can use the SG90, which is the plastic geared version, the little blue ones that often come with your Arduino kits. So that sets it to the correct frequency, whereas if we were using an LED on here, we'd have to have a different frequency. Now in the loop, a little bit, the code isn't too bad, but basically what it's doing is it's cycling the servo between US min and US max, and then it waits half a second, then it does the opposite. So basically it's moving the servo between 600 and 2400, which is the equivalent of going from an angle of 0 to 180. So if you run that sketch, guess what's going to happen? Your servo is going to move backwards and forwards through 180 degrees. Now, I don't know about you, but when I'm working with servos, I just want to put the angle in that I want the servo to move to. That's how the Arduino servo library works, and that's what we're going to do next. So let's get rid of this one and bring up the next sketch, Servo 2. So everything is the same here, and let's just go through the sketch so you can start to see how this is working. So the wire library is included because that is the I2C or I2C interface. That gets that bit working. This, the Adafruit PWM Servo Driver H, that is the library that we are using to control this board. And then here we have an instance of the library being set up, and we're going to call our instance PWM for this example. Now sometimes if I'm using a number of these boards, I will actually put board 1, board 2, board 3 with a different reference. You'll notice the default method of starting this, if we've only got one board set to the default address, this is all you need to do. Just leave that line like that. If, however, you've soldered one of the pads, and when you did our tester where we used that example of the wire library, we used the I2C scanner. Let's imagine you've soldered across one of those pads and now you've got an address of 41. This example won't work because it's going to be looking for board 40. In that case, you would put this line in and comment. So uncomment this one, comment that one out, and now you're going to be calling board 41 or whatever address came in, and you can actually put in a different way as well. I tend to use this method for my boards when I'm using multiple addresses. Now we're going to leave this US min 600, US max 2400 and servo frequency 50. We're going to leave them in, and you don't need to worry about those because I'm going to take care of them for you. Now the servo I'm using, because I'm plugged into port 0, again let's just remind ourselves 0 is the end nearest the pins where it comes in, that is 0, and it goes 0 to 15, so you've got 16 ports. Let's get back to our example. So we're going to be using 0 for our examples. We are starting the PWM board up. We have a delay, just a very tiny delay. This just allows things to settle down. And then what we're going to do is I have written a function. Now usually I would put the functions above the setup, but to make life easier so we can switch backwards and forwards, I've put this just above the main loop. So in the main loop we're going to use an integer q. If you're wondering why I use q, I'm a lazy programmer and q is top left on the keyboard. It's as simple as that. I just use it as a counter. I don't want to give it a long name because I can mistype that. So what I'm going to say is, while q equals to 0 or q is smaller than 180, so those are the angles 0 to 179, the servo moves 180 degrees, but of course it starts at 0 and goes to 179 rather than 1 to 180. That's just programming. We tend to start at 0, and all it's doing is passing the servo number, which is 0 for the port that we're plugged in, and the value of q. So all this is doing then is it's passing this to my little function, just so you know there. So we've got our servo coming through, we've got our position that's coming through. Now the position, one of the things this code does is it checks, is this greater than 179? Because if it is, the servo's not going there. So if this is greater than 179, it's going to just put 179. The same if you try to put a value that's lower than 0, it's going to put a value of 0 in. We're not going to go to minus values. Now with a little bit of mathematics that I've done, it now translates this value that we've sent over as an angle in degrees, and with a bit of mathematics it now sends that to the servo. So now where we're sending angles of 0 to 179 and then back again, you will see your servo sweep backwards and forwards, almost like you were using the original servo library. Now just to make this even clearer, I did another sketch number 3. Again, all of the stuff up here is identical to what has gone before. Now I've actually put the set servo position function above the setup routine, which is where it should go for nice clean programming for those of us who are fussy about those things. And this time, instead of doing something where we're going from q equals 0 to q is smaller than 179, I've just made this dead simple for you. we're going to set the servo. We're going to use our servo number, which we're still plugged in to 0. If you change that to 1 and plugged it into port 1, guess what? It'll work on port 1. So we're sending a value to our servo and we're telling it we want it to go to a position of 0 degrees. Your servo is going to move to that position. It's going to wait half a second and then we're going to send it to 90 degrees. Guess what? You'll see your servo move half a second later. Then we're going to send it to the other extreme to 179 and then we're going to go back to 90. So now instead of the servo moving with smooth movements, it's going to sort of be jerking from one position to the next and then stopping. For someone like myself who would be doing model railways where I want to use point or turnout control, I actually want to move the servo to a position and I want it to stop there. So this is more along the lines of what I would be doing. Now, in this sketch and all the other sketches, we have used delay. I don't like using delay, but at the moment we're just learning a lesson of how to control this servo using this function that I've written. And I'm just going to bring up the last sketch, and in this last sketch, again, absolutely identical until we get down to the loop. We've got the same as in sketch 3 where we're going to move servo 0, but this time a little bit further up I've got servo 0 equals 0, servo 3 equals 3. So now what I'm doing is I've got a servo plugged into port 0 and I've got one plugged into port 3. Now you could plug it into any of the ports, and if you change the number in the code, that port will move. But I just wanted to show this so that you're seeing two servos move. So we're moving servo 0 through a set of steps, and then that's going to stop, and servo 3 is going to go through its set of steps. Now you could add as many servos up to your full 16 in here if you wanted, and you can put these in any order that you want. You can move two at the same time. I've just done it like this to keep it clear. But what I'm hoping is that from this you can start to see that if you want to do simple servo control, all you need to do is keep this bit of code exactly as it is, include this particular function exactly as it is. You can then call your servos whatever you want, however many servos you want, and then all you've got to do is set your servo position with your servo and the angle that you want to do, and that way you've got now a very simple way of moving your servos from one position to another. So I hope that's been useful for you. This is part of a bigger project, so I'm just working on the next tutorial where we'll start to introduce buttons to move the servos to different positions. And obviously it won't be using delay, we'll be using millis so that we don't have blocking code. I hope that has been useful to you, and I'll get the next tutorial out as quickly as possible. And if it has been useful, please click the like and subscribe. See you soon.